This program will discuss the general safety and health hazards associated with welding and cutting, and examine hazards and controls specific to oxyfuel gas welding, cutting, and arc welding. The hazards associated with welding and cutting arise from toxic gases and fumes, radiation, electrical circuits, inflammable and combustible materials. Chemical agents commonly encountered in welding include the fumes of nickel, zinc, iron oxide, copper, cadmium, fluorides, manganese, and chromium, and gases such as carbon monoxide, oxides of nitrogen, and ozone. Physical agents include visible, infrared, and ultraviolet radiation, noise, vibration, thermal energy, and electrical energy. Fumes generated during welding and cutting operations may arise from the base metal being worked on, from coatings previously applied to the base metal, from the flux present, or from the filler metal being used. Other than fumes, other solid materials, such as fluxes and filler metal, may enter the air as fugitive dusts. Mineral and metal dusts may also be produced. Fumes may produce a variety of effects. For instance, metal fume fever is an acute disease of short duration caused by the inhalation of metal oxide fumes, such as zinc, copper, and magnesium. Symptoms include respiratory disturbances resembling an infection, influenza, fever, acute bronchitis, pneumonia. Chills, shivering, trembling, nausea, and vomiting may also occur. These symptoms most frequently occur after the first exposure following a period of relief, such as a Monday after a weekend off. In addition, welders exposed to fumes containing such substances as iron, chromium, chromates, lead, and aluminum may suffer damage to the lungs, lung cancer, possible nervous system problems, and irritation to the eyes, nose, throat, and lungs. Injuries to the eye occur when eye protection is either not properly worn or not worn at all to protect against the electrical welding arc. These injuries include keratitis, penetration, and retinal injury, such as welder's flash. Exposure of the skin to ultraviolet radiation from welding and cutting can result in a skin burn resembling a severe sunburn. Chronic dermatosis may also result from welding torch radiation. Hearing loss may be suffered due to hazardous noise levels or traumatic injury to the ear caused by flying metal. Another hazard resulting from welding and cutting is reduced muscle power and pain in the shoulders. These are caused by static and often distorted postures adopted during welding operations. The fire hazards caused by welding and cutting are due either to the direct flame or to flying sparks and molten metal. Explosions may be caused when welding sparks ignite flammable or explosive materials. An oxyfuel gas welding process unites metals by heating them with the flame from the combustion of a fuel gas or gases. Sometimes the process includes the use of pressure and a filler metal. It's hard to believe that something as vital to life as oxygen can be a deadly hazard as well. But in fact, it can be. The presence of oxygen is required to support any burning process. Oxygen must be combined with a fuel gas to produce the desired operating flame. Oxygen itself is not flammable or explosive. However, the presence of pure oxygen dramatically increases the speed and force with which burning takes place. Combustible materials burn much more rapidly in pure oxygen than in air. Oxygen also forms explosive mixtures in certain proportions with acetylene and other flammable gases. However, this hazard can be controlled. This oxygen cylinder has been labeled with its proper name, oxygen. Oxygen cylinders must never be labeled air. Serious injury may result if oxygen is used as a substitute for compressed air, such as for purging hazardous atmospheres. Oxygen is ordinarily supplied in standard drawn steel cylinders. The amount of oxygen remaining in the cylinder can be determined by reading the cylinder pressure gauge on the regulator when in use. The maximum charging pressure is always stamped on the cylinder. In oxygen cylinders, there is as much as 2,600 pounds per square inch, PSIG pressure. When the pressure is released from the cylinder through the regulator, the speed at which the oxygen travels exceeds the speed of sound, and heat and friction are generated. Oil and grease become highly explosive when mixed with oxygen. Acetylene is another hazardous gas used in gas welding. Acetylene is a combination of carbon and hydrogen. Serious accidents can result from the misuse and mishandling of compressed gas cylinders. Compressed gas cylinders should be legibly marked with either the chemical or the trade name of the gas. Whenever practical, the marking shall be located on the shoulder of the cylinder. These cylinders have been properly marked. Only cylinders carrying the approval of the U.S. Department of Transportation shall be used. Cylinders may be moved by tilting and rolling them on their bottom edges, but it is best to secure them in a suitable cart. OSHA stipulates that cylinders shall not be dragged, dropped, or struck, or permitted to strike each other violently. These valve protection caps are designed to protect valves from damage and to avoid an unguided missile in case of knocking off the unprotected valve. They are required on all cylinders with a watertight capacity of over 30 pounds. They are not to be used for lifting cylinders from one place to another. Empty cylinders should be marked with the word empty and separated from full cylinders to avoid confusion. Empties should be returned to the supplier as soon as possible. When gas cylinders are used, the special T-wrench or key for opening or closing the cylinder valve must always be in position for use so that the gas can be turned off quickly in an emergency. OSHA standards stipulate that acetylene cylinder valves shall not be opened more than 1 1/2 turns and preferably not more than 3/4 of a turn. Pressure gauges should be tested periodically for accuracy by a competent welding engineer. If the gauges have been strained so that the hands do not register properly, the regulator must be replaced or repaired before it is used again. If a regulator creeps, the cylinder should be closed and the regulator removed for repairs. Creeping is indicated by a gradual increase in the pressure after the torch valves are closed. The reverse flow check valve on the regulator and torch handle reduces the possibility of the formation of mixed gases, which will burn rapidly and can explode in the hoses, regulators, or cylinders. Oxygen and acetylene hoses shall be color-coded to prevent confusion. According to American National Standards Institute, the generally recognized colors are red for fuel gas hose, green for oxygen hose, and black for inert gas and air hose. The welder should always verify proper connections before starting work. Standard hose connections are threaded right hand for oxygen and left hand for acetylene or other fuel gas. This helps prevent an accidental switch of oxygen and fuel gas hoses. Oxygen and fuel gas hoses are not to be used interchangeably. A single hose with more than one gas passage should not be used. Arc welding creates problems of its own. Arc welding is a group of processes which produces coalescence of metals by heating them with an arc, with or without the application of pressure, and with or without the use of filler material. Arc cutting is a generic term for carbon arc cutting, gas metal arc cutting, gas tungsten arc cutting, metal arc cutting, plasma arc cutting, shielded metal arc cutting, oxygen cutting, especially useful for metals that do not oxidize readily, and air carbon arc cutting. The principal hazards presented by arc welding are intense ultraviolet, visible, and infrared radiation, production of toxic gases such as ozone, nitrogen oxides, and carbon monoxide, action of ultraviolet rays and thermal decomposition on chlorinated hydrocarbon vapors, production of toxic fumes from melting toxic metals or metal alloy, splatter of molten metal, mishandling high-pressure gas in cylinders and manifolds, and electrical shock. Ultraviolet radiation is produced in arc welding when using shielding gas. Arc welding operations should be isolated so that other workers will not be exposed to either direct or reflected rays. Walls, ceilings, and other exposed inner surfaces should be painted with a finish of low reflectivity, such as zinc oxide or lamp black. Arc welding stations for regular production work can be enclosed in booths, if the size of the work permits this. The inside of the booth should be provided with portable, non-combustible, or flame-resistant screens or curtains. Booths and screens shall permit circulation of air at floor level. For many welding and cutting operations, control of gases and fumes by dilution ventilation is sufficient. That is, enough fresh air can be added to the contaminated air to prevent a hazardous buildup of toxic chemicals. However, the effectiveness of dilution ventilation depends on several factors: the size of the space in which welding or cutting is done, the total number of welders working within the space, the hazardous chemical or physical agents produced by the welding or cutting. Arc welding is done with either a metallic or a carbon electrode. For gas metal arc welding, the electrode is a solid or flux cored wire. For shielded metal arc welding, the electrode is a covered wire. The electrode holder consists of an insulated handle and a clamping device for holding the electrode. The electrode can be gripped firmly at any angle and held in that position. A fully insulated electrode holder reduces the likelihood of accidentally striking an arc. Connections between the cable and the holder must be checked to be certain they are not loose. The jaws of the electrode holder should be maintained tight and the gripping surfaces in good condition to provide close contact with the electrodes. Defective jaws will permit the electrode to wobble and will render control of the welding operations difficult, causing overheating and arcing. The connection of the electrode lead to the holder should be either soldered or brazed. When welding is to be interrupted for any substantial period of time, such as during lunch or overnight, OSHA requires that the machine be disconnected from the power source, that all electrodes be removed from the holders, and that the holders be carefully placed so that accidental contact cannot occur. When changing electrodes, the worker must be on a dry surface and wear gloves. When not in use, the electrode holder must never be left in contact with the tabletop or other metallic surfaces which are in direct contact with the welding ground. An insulated hook or holder should be provided for the electrode holder when not in use. The holder in contact with the ground circuit causes a dead short circuit on the welding generator. Should the machine be started up, this short circuit would cause an excessive load on the motor and could damage the insulation and fuses. Because of the hazards created by welding and cutting operations, great care shall be taken in determining work sites so that they do not create fire hazards or endanger workers nearby. Because of the potential for fire and explosion, OSHA lists 4 locations where cutting or welding shall not be permitted. 1. In the presence of explosive atmospheres, mixtures of flammable gases, vapors, liquids, or dusts with air. 2. In areas near the storage of large quantities of exposed, readily ignitable materials. 3. In sprinklered buildings while such protection is impaired. 4. In areas not authorized by management. It is good practice to provide each welding booth with a Class B and C fire extinguisher of a dry chemical, multipurpose, or carbon dioxide type. According to OSHA standards, cutting or welding shall be permitted only in areas that are or have been made fire safe. Training should be given to all workers on the hazards in welding and cutting operations. The training should be specific to the type of operation, location, and kinds of materials that are to be cut or welded. The training should include hazard recognition, hazard evaluation, and hazard control. Training in the care and use of personal protective clothing and equipment is necessary for the safety and health of the worker. Training should include fire protection and safe work practices. The general safety and health hazards arising from welding and cutting operations result from a number of conditions and affect workers in a number of ways. This program has described some of the hazards and methods to control them. Utilization of control measures suggested in this presentation will aid in the reduction of workplace hazards associated with welding. Conscientious practice of the control measures described and strict adherence to the standards can reduce dramatically the number and severity of accidents and illnesses resulting from welding and cutting hazards.